Hey everyone, fine-tuning for GPT-4o is finally available and it is free until September 23. So we'll be getting 1 million training tokens per day for free until 2020, until September 23. Otherwise, it costs $25 per million token to train GPT-4o, and also 2 million tokens for GPT-4o mini is free tokens is still in effect. I have actually went ahead and trained the GPT-4o model, as you can see, along with some GPT-4o mini models as well, to actually generate code based on the winners of the synthetic synthetic thought frameworks video that I've made. And so we will go through several files, generate instructions which will actually generate this code. We will use these as the system user message. And then we will create the data sets both with the unified file and the system message and without. We'll talk about all of that. And then finally, how to use the fine-tuned model as well and compare how Mini and GPT-4o compares. Code files for this project will be available at my Patreon for connoisseur level patrons. But the apps in the winners directory, along with the code files, will be available for at the Architect Plus level, just so you know the difference. So let's begin and see how all this works. Let's start with a quick demo. Now I'm going to use the non-mini version of the fine tunes, this one. So let me just run this. So this is designed to actually use the unified class that I've created that just simplifies using all three providers, Claude, OpenAI, and Gemini from OpenRouter. In any case, when we run this, all we have to do is just enter a task description, such as let's ask something like an agent system where a controller agent assigns tasks, let's say tasks to three other coding agents and saves the final code to final code.py. When we do this, we're going to get a code result, which we'll save here as response.py. You can also iterate on it. Okay, here we go. This is our response. As you can see, it's using the unified. It has created the controller agent and other agents, as well as their system messages. The tasks are going to be given by the controller agent. So now we can actually try to run this. Let's open a new command prompt, type in Python response, and it initialized all the agents. And it is working on a Python script that scrapes and analyzes trending topics from Twitter. And as you can see, it created a plan and it created tasks for each of the agents, task 1, task 2, and task 3. And at the end, we are supposed to save the final code to final code.py. And here is it. It's using Tweepy. And it wrote quite a complex project, maybe made a few errors, but I guess it just didn't extract the code perfectly. It just appended all of it, but nevertheless, it was able to create an agent-like system. So this is roughly how it works. We are using the fine-tuned model. Let's we can say a doc summarizer, for example, and it's fine-tuned to actually create LLM apps. And here is a doc summarizer, for example, with multiple agents working together. So it's fine-tuned to actually create complex systems like this using LLMs. I also created a web app that does the same thing using the GPT-4o mini model. And if you become a patron, you'll be able to use this. This is available for my architect level patrons. You just need the access code. So my architect plus patrons can actually interact with it through here. This is how it works. For example, I can say summarizer, and it will generate the code and you can iterate on it as well. Here we go. It wrote the code here. You can copy the code. You can download the zip file. When you download it, it downloads it along with the unified.py file, which this script depends upon. And you can also say Streamlit app. So it will now modify this to become a Streamlit app. Here we go. That's to create the Streamlit app here. creates 95% of the time working code. So this works very well. Now let's actually take a look at how we are able to create the JSON-L files and actually fine-tune the model. So we're going to start with this winners folder because this winners folder have a bunch of apps that rely on Unified API, which we have built using the synthetic thought frameworks. If you're interested in what is the video right before this one, synthetic thought frameworks for novel code generation. Take a look at that video. But so we had all these code files, but so now we want to fine tune a model that can actually generate them on the fly with simple descriptions. So therefore, we need instructive descriptions for each one of these apps. For example, this accessible e-commerce AI assistant has this description, but this description was AI generated. So these text files wasn't here to begin with, like originally. So here I have this description gen.py file, which actually opens every .py file. And we are going to send it to unified.chat async from the unified class to actually generate the description. And the instruction is you are an AI assistant that generates non-technical descriptions of Python code. Please provide a brief general description of the code's functionality in a few short sentences, such as, an app for or the code that does, right? And we are using JSON mode here. We have initialized to use GPT-4o mini. And then we pretty much read the files and then write the text files back into the folder with the same name. And we use async, of course, to create all the tasks, for example. So we can do all of them simultaneously. If I were to do the first 5, like this, when we reach length 5, then we break. Now when we run this, sorry about that, we should initialize 5, and we are getting their descriptions all in parallel. And these descriptions are written to text files. So this is going to be the user message. Is almost like an instruction that we will give to the fine-tuned model as the data set. And then the output of that we will give as the code file. So this actually works well. If we look at another example, it says an app for managing user interaction preferences to an adaptive AI assistant. The point is to have simple instructions so that you can actually instruct the model with simple instructions and it'll learn to generate complex code using the unified file. So now that we're done with that, we have the descriptions written in a text file with the same name for each and every one of them. There's about 170 of them here. Next one is the dataset gen.py. Excuse me to tell you about the ECOIF hackathon that is running until the end of this month. Prices will be the first place will get 1 hour one-on-one meeting with me, $150 value. Second and third place will get half an hour meeting with me, $75 value. All top 5 projects will be demoed during the YouTube live stream when the hackathon ends, and all of the owners' repos will be mentioned in the live stream. This is for Architect Plus patrons only. Link will be in the description if you're interested. Just going to read the file's contents and then take a directory, which is the winners directory. And then it's going to create the data set, these data sets. Now we're going to create 2 options. If you look here, each data set consists of like this object, which a system message, a user role, and an assistant role. The system message is your AI assistant that helps create Python code based on project descriptions using the unified class from unified.py. And then the user message is the descriptions which we had just generated. And the assistant is the code that we have right in the winners folder. So this is what the dataset gem will do. But as you can see, I have 2 JSON-L datasets. In one, I am actually just giving a simple single sentence system message, but in the other one, I am actually giving the entire contents of the unified.py file. So I wanted to see if that makes a difference. And in my experience, it actually works so much better when you give the instructions in the system message, the content of the unified.py file, because it's going to be building apps based on this. So that's why we have in the generate dataset this included unified, which is going to be a boolean. We ask, do you want to include the contents of unified.py file in the system message? and we are going to read it if this is true. And then we're going to create an if string saying here's the content of the unified.py, which we add right here. Say here's the content, end of the regular system message that we are defining. So, and we're just going to read through all of the files. We're going to have our regular system message, read the user message from the text file for each corresponding Python files. And then we will get the system message, which is going to be the content of .py, and we are going to create a messages list consisting of system, user, and assistant. We're going to append it all, and we're going to write it as a dataset.jsonl. So now if I run this real quick, it's going to ask us if we want to include the contents of Unified. I'm going to say yes. And it's going to create this dataset.jsonl, which is identical to the dataset with Unified JSONL. So now we have our dataset, we can actually fine tune, but I created this count tokens.py file, which is actually going to count the tokens for us. Let's run this real quick. We do have to insert the correct folder, correct file, which is going to be the dataset.jsonl, which is the one we just created. So when we run this, it's going to count tokens, and we have a total of 711,000 tokens in our dataset, which is within the limit of 1 million free tokens for GPT-4o. And as you can see, we have a total of 173 entries, meaning we have 173 examples. OpenAI recommends a few dozen examples to start getting decent results from GPT-4o. And so before we continue to reviewing the code for count tokens, let me actually show you that how we can fine tune. So to fine tune, go to your dashboard and go to fine tuning and click on create. Here you're going to select your base model. You can select the GPT-4o right here or GPT-4o mini. Let's say GPT-4o mini. And then you need to upload your data set. Let's select the data set with unified JSONL. And it'll verify it, and it should be verified just fine. Here you can enter some suffixes, for example, something like unified app builder, whatever it is, you can enter. So this will be an identifier. And you can enter some custom hyperparameter configurations, but essentially I didn't. I just click create. I'm not going to start it now, but I have done this. When you do that, it will verify your files. And as long as everything's in order, it'll start your fine tuning session. You will see the training loss along with these metrics, displaying how many steps and whatnot. And when it's done, you will receive your final model, and you can see which model it was based on. And as you can see, this Unified App Maker Mini with Unified 2 is this suffix that I've entered right here. So you can create a nice identifier here. So this is pretty much how it works. If you do this, GPT-4o mini fine tuning is pretty fast, but GPT-4o fine tuning actually takes quite some time. And you can only fine tune one at a time. So there's a rate limit. Just remember that. Now let's take a look at quickly how we're counting the tokens. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours over projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. We're using TikToken. Just going to open a file, and we're going to use CL100K base, which is GPT-4 encoding. And we're going to encode the text, and we just return the length of tokens. But to do that, we're going to initialize a total tokens counter and a PyFiles counter, so we can print how many files there are. We're also going to count the number of entries in the dataset.jsonl. I forgot to mention that we are also counting the total tokens in .py file in all the .py and .txt files, which is going to mainly make up our dataset. As you can see, it's only 154,000 tokens, but our dataset is 711,000 tokens because we are including the entire content of unified.py in every instance of the dataset. So we're going to count the tokens in the directory. We're going to loop over every .py and .txt file, call to count tokens in it, accumulate the tokens, and essentially just print them, and increase the py files count by 1 so we can see how many files we have, which is 180. I don't know why this ended up only 173, probably related to the encoding UTF-8. And we are counting the tokens in dataset by very much the same way, except we are just reading the file one time, which is going to be our dataset file name, but everything else remains the same. Here we are reading the entire files of the folder and printing the token, and here we are reading the entire content of the dataset.jsonl and printing the tokens and number of entries. So, and this is what is displayed right here. Anyway, after your fine-tuning is successful, then you can now use this and use fine-tune model, which as we have seen in the beginning of the video. Here I have some conditional statements. So this is just going to read a system message from the first line of the dataset. I did this because we have options, right? We can actually use the fine-tune model, which is fine-tuned with the unified class in the system message or not. So that's why I wanted to read it from the data sets, because I have both the with and without unified right here. And you can change these options here, of course, depending on how you want to use it. Here, if we're using the unified and the mini model, then we have the name of the model as that fine-tune. Otherwise, we use the GPT-4o model. And if we are not using the unified, then we are using the GPT-4o mini fine-tune without unified in system message. And we initialize our unified APIs based on the unified .py file. We read the system message. We set the system message using the set system message method of the unified .py. And then here we say, enter your description. This is all the user input you need, but I have additional instructions added just in case if the model fails. Can add additional instructions to kind of remedy that fact, such as the fact that only OpenAI models can use JSON mode. I actually fixed this later by improving the dataset. As you can see, I put some instructions at the bottom of the unified.py file, which automatically goes into the system message of each dataset entry. But originally, before I did this, I was using this user input, but I just left it there. So you can change this, because sometimes the model will make common mistakes that it will do in every request. And you can actually fix these like this. The important thing I should have mentioned is that the system message that you use for fine-tuning has to be the exact same when you're actually inferencing with the model. That's why I didn't want to put these instructions in a system message. If you change the system message to something else other than what you use for fine-tuning, then your results are going to really suffer quality-wise. So then pretty much we just call with the user input the .chat method, which calls the proper models, whichever one you've specified. And this is the response. And because we fine-tuned it to directly return the code examples, it usually follows that. But if you're iterating, it can return this triple backticks Python and triple backticks. So we're checking for that. If it does do that, we are retrieving the code from in between and saying that generated code is that. If there is no triple backtick Python in the code generation, then we take the response as it is and just write it to response.py file. For example, let's run this again then, and it's going to ask, well, we do have to change the options here. For example, use unified true and use mini true. So we can use the mini example. Let's just ask for a complex agent system with 5 agents. As you can see, there's no problem. It's initializing 5 agents. It's quite fast too. And it just saved it right here. And I think I accidentally pressed enter again. Can break out of this. So it's going to initialize 5 agents. You're an AI model that analyzes user requests, classifies them into categories. Wants to use JSON mode. You're an AI model that provides detailed explanation justification for categorized requests. We asked for an agent system, but we didn't ask what for. So it's kind of creating this. you're a different AI model that specializes in handling time-sensitive categories, creative solutions. So this is pretty interesting. Let's see, actually, this will work without any errors. It initialized. Oh, yeah, there we go. It is doing that. I wonder what the user input was. I need urgent assistance with my account security. So all 5 agents are going having a go at it, as you can see. This is fantastic. So this really simplifies your life, right? And if you're an architect patron, of course, you can use the Unified App Generator. I'll put the link in the description. All you have to do is when you become a patron, go to this post, which is linked right here, and input your key. Once you've entered it, then it's good to go. It should stay validated. But if you have any issues, do let me know. I hope to train a better model and add some model selection here too, but it works well. Yeah, this is about it. I hope you found this useful. If you are enjoying my content, check out my website at echohive.live, where I have over 350 free coding videos now. And if you're a patron, you can download the project files for any one of them, such as the web researcher with task scheduler. Just click here. If you're not a patron, you'll be prompted to join. If not, you can download the code files for each project at the bottom of each post. I also have free not free, but for patrons courses, especially the 1000x masterclass, in which I teach cursor building projects from scratch. Each one of these zip files include the video, full coding walkthrough video, along with the project files. This is level patrons. My patrons really do. If you're interested in becoming a faster coder, I highly recommend this. I update this on a regular basis. We also have tiers in which you can contact with me one-on-one. Those are higher tiers you can find on my Patreon. And if you're an Architect Plus member, you don't forget that we have weekly AMA and live coding meetings. Look for those links as well.